And the first part of chapter 2 deals with absolute values. So a couple of definitions that we're going to highlight here. Take out my highlighter. We say the magnitude of a number is how far it is away from 0. And we write that with an absolute value sign. So when we want to find out how far something is away from 0, we put absolute value lines around the number. So if I'm like, ooh, really tough question. How far is 4 from 0? It's 4 away. How far is negative 2 away from 0? It's 2 away. Not very hard. Okay? What ends up happening for most students is they forget that the absolute value bars mean how far away it is from 0 because they use a shortcut. The shortcut they use is they say, ooh, this just makes whatever number's inside positive. If the number is positive, it stays. If the number is negative, it changes to positive. Which is a good shortcut for doing math stuff, but it's always important to realize, where did this come from? So when I say, what's the absolute value of negative 10? It's asking how far away is negative 10 away from 0? Well, it's such an easy math question. It's going to be positive 10. So you're going to, I hope, everybody's going to remember that absolute values change things positive. Okay? That's going to be your easy thing to remember because you do it over and over again. But I hope you remember the overall idea that really it's a distance. How far away is that number away from 0? And you might even see later on in other courses that they start using those straight lines to calculate different kinds of distances. Okay. So, other things from the past that are important. Do you remember your different number families and the symbols that we use for them? Your natural numbers are your counting numbers. 1, 2, 3, 4, 5. Your whole numbers, just add 0. Integers are positive and negative whole numbers. Rational numbers are anything that can be written as a fraction. So negative 2, you can write as negative 2 over 1. You can write it as a fraction. It's a rational number. Decimals, any decimal that ends 3.21, well, that's 3 and 21 1/100ths. You can write it as a fraction. And any decimal that repeats, which we kind of talked about already, like if I had 4.32 repeated, anything that's repeated can be over 9s. So any repeated decimal is also a rational number. So rational numbers are anything that can be dealt with as fractions. One of the big things that we're going to be looking at in the second part of this unit is irrational numbers. Numbers that can't be written as fractions. And lots of square roots, like square root of 3 is an irrational number. But square root of 4 is not. Why isn't square root of 4? Because it's equal to 2. So some square roots are equal to nice numbers, therefore they're not irrational numbers, but other ones are not. I think you probably learned the irrational number pi. Next year or next semester for some of you, you're going to learn the irrational number e. It's on your calculator. You can find the e, push equals, and it's like 2.718, da 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 da, keeps on going. It's another irrational number. And then putting them all together is the real numbers. Okay? And you've seen this notation, like if we write, for example, you might have written in grade 10 the domain of a line that x belongs to all real numbers. That means x can be any real number, everything is possible. Sometimes in math, you're not allowed to use all the real numbers. Sometimes you can only use positive numbers. Sometimes only negative numbers. Right? Because if I wanted to square root something, x has to be positive because you can't square root negative numbers. X could be 0. So it can be only positive real numbers. So we're going to look a lot at working with what's possible and what's not. Okay? But the absolute value, it says here at the end, and I can highlight it, using these conventions, the absolute value of a number a is the distance from a to 0 on the number line. And you could do that with any number. What's the absolute value of the square root of 2? The square root of 2. What's the absolute value of negative pi? Pi. So, our absolute value signs are going to make things positive because it's calculating how far something is away from 0. So with that, we can go to example 1. And each of these you can calculate, like absolute value 4.2, 4.2. Absolute value of negative 6.1, positive 6.1. Absolute value of negative 3/4, 3/4. And absolute value of negative 1/2, 1/2. And if I had to put these on a number line, 1, 2, 3. This dot here would be the absolute value of 4.2. It's hard for me not to just write 4.2 because that's what it's equal to. But I'm going to try to label them with their absolute values. Like negative 6.1 is 6.1. So this is where it would be on the number line. If I labeled it with the absolute value, I just want to write 6.1 because I'd like to simplify these all. It makes it more easy to visualize. If I like negative 3/4, I would be like, I just want to write here 3/4, but I can write it this way as well. Same thing with negative 1/2. So from least to greatest, it would go red, orange, green, purple. No problem. So we now know that the red one's the smallest, then the orange one, then the green one, then the purple one. And from least to greatest, it's just how far away they are from 0. Okay, you can circle question 3. 4, 7, and 9. We're going to do a couple more. We're going to do one more question, and then I'll give you time to work on things.